Alrighty, so here we are. We are factoring completely. Now, sometimes they'll phrase things, which of the following is a factor of this trinomial? In which case you'll need to factor it and take a look at what your factors are in your final answer. And hopefully they match a factor listed as one of your options. Always look for a GCF. However, in this problem, I do not see a GCF. And unfortunately, the A value right here is greater than 1. So, we're not going to look for numbers that multiply to this -4. We're going to multiply our A and our C value together. And if you're not sure what A, B, and C are, you better get on that because for the quadratic formula, it's super important. You're going to look for numbers that multiply to A times C, which is -16, and add to your B value, which is 15. And so we would have 16 and -1. That multiplies to -16 and adds to 15. So then we're going to use the technique called split the middle. I'm going to rewrite this trinomial that's up above, but I'm going to rewrite it with 4 terms. And instead of writing 15n in the middle, I'm going to write 16n minus 1n, which is 15n. So it's equivalent but extra. And you're like, well, why do I have to do that? Because it's going to help us factor this thing. Sometimes we have to add a little more on or invest a little bit into this problem to make it doable, to get through it. So, again, in the initial problem, there was no GCF. And in this polynomial with 4 terms, there is no GCF. But check this out. We've learned that if there's a polynomial with 4 terms, we can factor by grouping. Now, careful, this one has a third term that's negative. And when that happens, chop slash, because this negative sign needs to get placed in the parentheses. So there's a plus sign right here, but the third term's not positive. So I put a negative sign in there. So now, try to factor something out of the first 2 terms. The 4n squared plus 16n, you can factor out a 4n. What remains inside is 4n. Oops, just kidding. What remains inside is n plus 4. Now try to factor something out of the second, or the last 2 terms, the third and fourth term. And there you might say, well, there's nothing to factor out. If in factor by grouping, if there's nothing to factor out, you have to factor out a 1. However, in this case, I want to factor out a -1 because, remember, with factor by grouping, kind of a nice way to assure that you're getting it right is what's left in the parentheses here, when you take out a GCF of the first 2, better match what's left in the parentheses of the last 2. So when I factor out a -1, what remains inside is a positive n, which matches over there, and a positive 4, which matches the other binomial. So this matches perfectly, folks, and now you can factor out a 4n and a -1, or just regroup this. That's why they call it factor by grouping, kind of. Regroup it this way. The binomial that is matching is one of your factors. The other factor is those GCFs that you were able to factor out earlier. So this trinomial has 2 factors. One of them is 4n minus 1, and the other one is n plus 4. And I would hope that one of them shows up down below as one of my answers. Let's try that again with number 22. Again, there is no GCF. So I'm going to factor this trinomial, and unfortunately, A is bigger than 1. So I need to take A times C, which is 60. So I'm going to look for ways to multiply to 60 and add to my B value, which is -17. Please mind your signs, folks. That's a -17. So I think about ways to multiply to 60. 1 and 60, 2 and 30. And by the way, there's factor sheets, factors of 1 through 100, that if you really struggle making these, you could download. But it's a good skill to have. Now, I have this list, but if I'm trying to multiply to a positive 60, I could also use a negative, or 2 negatives for each of these pairs, right? Because 1 times 60 is 60, and so is -1 times -60, and -2 times -30, etc., etc. And I need to do this because, folks, while I'm multiplying to a positive, I'm adding to a negative 17. So this is the pair right here, negative 5 and negative 12, that satisfies both requirements. And then it might not hurt. I'm using the variable a in this trinomial, so go ahead and put a's with those because that might help you remember to split the middle. Instead of writing 17a, I'm going to write negative 5a and negative 12a. And then bring down your 4a squared and your positive 15. And now let's factor by grouping. So hug the first two, hug the last two. But the last two, see how this looks messy right here? Yeah, that's a good indication that, oh, I got to fix this up. So I'm going to put a plus sign here, but that's lying because the 12 is actually negative. So put a negative in there with the 12. It's a messy negative sign. You know what? Just going to rewrite it a little bit. Negative 12a plus 15. There we go. So now you try to factor out what you can out of each of these new groups. You can only factor an a out of the first binomial. So 4a minus 5 is what remains inside. What can we factor out of the second binomial? You could say a 3. Definitely a 3. However, when you factor out a 3, folks, notice this first term is positive 4a. And if I factor out just a 3, I'm going to get left with a negative 4a. Similarly, this is a negative 5, and if I factor out a 3 over here, I would have a positive 5, not the same number. These two parentheses need to match perfectly, and right now they're opposite of what they should be. So instead of factoring out a 3 from this second parentheses, I'm going to factor out a negative 3. Because when I factor out or divide by negative 3, it's going to make these terms opposite. So now I do get a 4a, and I do get a negative 5. Sweet, they match. Put your GCFs, or your mini GCFs, I call them, out in front. That's a and negative 3. And then multiply it by one of your matching binomials. And if you factor this together, folks, so this is your answer. Well, this is factored completely. If you multiply it together, if you FOIL it, it works and it equals what's up above. This trinomial right here. Now again, the directions say which of the following is a factor of this trinomial, and hopefully one of your options for the multiple choice, is either this one or that one. Like, they're both factors. I don't think they're going to show both of them. They're just going to show one of these. And if you didn't factor it completely, you wouldn't know that these are factors. Isn't that fun? Remember, folks, there are answers down below, but make sure you understand the process.